I'm going to play two chords for you on this piano, and you must tell me which one of them sounds more pleasant and which one of them sounds more tense. So you should have noticed that the first chord sounded quite nice, and we call that consonant, but the second one kind of didn't, and that's known as dissonant. But why exactly do some chords sound better than others? Let's start with how sound works. When something produces a sound, it's causing a vibration in nearby air molecules. These air molecules then go on to hit other air molecules, which hit other air molecules, and so on, kind of like dominoes. This can be modeled by a wave, where the amplitude measures the volume and the period determines the frequency. This frequency measures the pitch, so the greater the frequency,
the higher the pitch,
and the shorter the frequency,
the lower the pitch.
On the piano, all keys correspond to a different note which have a specific wave. Every 12 notes, the frequency of that wave doubles. Now, what would the sound wave for a chord or multiple notes look like? Well, as it turns out, it's really just as simple as adding together the waves of the notes in the chord. This is known as the principle of superposition. Here are the sound waves of the chords that I played earlier. Do you notice anything? Here, let me put up a few more. On the left are the consonant chords, and on the right are the dissonant chords. A pattern emerges. We can see that the consonant chords seem to be more clean and simple, while the dissonant chords are more messy and complex. But why exactly does this happen? Well, it all has to do with something known as frequency ratios. Frequency ratios describe the relationship between the waves of the notes in a chord. Since the frequency of a wave is directly related to its period, a more simplified ratio results in a cleaner wave and therefore more pleasant sound. Let's take a look at the chords we've shown earlier next to their frequency ratios. We can see that a consonant chord has a simplified ratio, while the dissonant ones are more complex. So next time you listen to some music, take a moment to listen for consonance and dissonance. And this time, you'll know exactly why it occurs.